Hello, in this question, we have to find the ratio of the speed of electrons in ground state of hydrogen atom, the speed of light in vacuum. So, we have to find speed of electron in the ground state upon speed of light. Now we know in the ground state speed is 2.2 10 to the power 6 meter per second or c upon 137, where c is the of light. So v upon c will be 1 by 137. Means option 3 is correct. Hello. This question you have to find out the wrong statement, not correct, of the Bohr's model in hydrogen atom. Electron in atom would revolve in certain stable orbit without the emission of radiant. True. Electron revolves around the nucleus only in those orbits where angular momentum is integral multiple of h upon 2 pi. So this is also correct. Third, when electron makes a transition from one orbit to another orbit, energy difference is 1 by this, and energy difference के ही हमको मिलेगा फोटॉन की क्या एनर्जी है density and wavelength. And fourth, Bohr's model is applicable to all atoms. It is not true for higher atoms and is not correct. So Bohr's model is not applicable to all atoms. It is applicable to only hydrogen atom correctly. So fourth statement is wrong. So here option is wrong. Here Pastchen series where n is equal to 3 and initial and n2 and final should be more than 3, means 4, 5, 6, 7, etc. So Pastchen series belongs to infrared region. First is Lyman series, UV rays. Second is Bohr series, Hubble, and all others are belonging to infrared regions. So option 1 is correct. Hello, in this question, for ground state, electron in each atom has an angular momentum according to the Bohr's model. Angular momentum is a vector quantity and there will be infinitely many possible orbits. So it's not true. Vector pointing in all possible directions because Bohr's model gives correct values for angular momentum. It is valid only for hydrogen atom. So this is the option. Option 1 is correct. Hello, this question, wavelength present in the P1 series of the spectral lines lies in which part? We have already discussed here Lyman series belonging to UV rays and Bohr series belonging to visible rays, visible spectrum only, whereas all others say Pastchen series, bracket series, series and Humphrey series all belonging to the infrared radiations. So here P1 belongs to infrared regions. Option 4 is correct. Must learn this बहुत बार repeat question here. Hello. In this question is the diagram shown here the energy levels of electron in certain atom, which transition shows the representing the emission of photons with most energy. So here is the emission spectrum. First of all, the emission means here the electron is jumping from higher orbit to lower orbit. It is a lower orbit to higher orbit absorbing energy. So that is called absorption spectrum. But here emission spectrum means electron is jumping from higher orbit to lower orbit. And here first is lower orbit n is equal to 1, 2, 3. So it is absorbing 2, 3, 4. All are emission spectrum. But maximum energy means E1 here. Total energy E1 is minus 13.6 upon 1 per electron volt. 2 means here minus 3.4 electron volt. 13.6 divided by 2 square 4. So that comes here. E3 will be minus 1.51 electron volt. 13.6 upon 9. E4 will be 0.85. We are talking about the hydrogen atom. E5 will be minus 0.54 electron volt. So here if we are talking about the maximum means here the difference between 1 and 2, first orbit to second orbit, it gives here 10.2 इलेक्ट्रॉन वोल्ट डिफरेंस एंड बाकी इसमें सब में सबसे ज्यादा आ रहा है मीन्स मोस्ट एनर्जी. तो 2 to 1 here this is the possibility here 2 to 1 and emissions from higher to lower means option 3 is correct. Here in this question oxygen molecule consists of two oxygen atoms. In the molecule nuclear force between the two nuclei, we know the nuclear force is very large force, much more than the electrostatic forces, whether it is attractive or repulsive. It means when we are talking about the oxygen molecule, the nuclear force is invalid. Reason behind here is nuclear forces are short range force. They are the short range force. So it is not applicable to large distance. So for molecules, electrons, we are not talking about the nuclear force. It is not important here. Nuclear force is not important here for the molecule. They are acting between the nucleons within the gas only. So here option 1 is correct. Hello, in this question, in Geiger-Marsden or Rutherford experiment, find the distance of closest approach to this energy of alpha particle. So at this distance of closest approach, it comes momentarily at rest and then bouncing back, reversing back for gold nucleus. Now here we know the distance of closest approach formula here is R naught equal to K, the constant quantity K, 1 upon 4 pi epsilon naught Z E square for kinetic energy. Here Z is this. Hello, we know the formula of distance of closest approach given by this. If initially the Geiger-Marsden and Rutherford, they have taken the energy of mv square of alpha particle 5.5 billion electron volt, then are not coming here roughly 45 Fermi. 1 Fermi is 10 to the minus 15 meter. If they increase the energy up to say 7.7 million electron volt, this radius, because if increasing this energy, radius will be decreasing. It is roughly 30 Fermi. Though information given here, suppose we take more energy, then alpha particle may collide with the gold nucleus. That's why they have not taken higher energy, because energy we are interested to find out the distance of closest approach, not colliding alpha particle of say gold nucleus. That's why in this experiment, they have taken this energy, the maximum energy for which the alpha particle is going closest to the nucleus but not colliding. So here, for this energy, 30 Fermi. दोनों याद रखें. So learn it. Means option 3 is correct. And this question, which of the spectral series in visible spectrum हमको learn किया हुआ है. This is for Bohr series. Visible spectrum for Bohr series only. So option 4 is correct. Lyman series for UV rays, and this first and second belong to infrared. So here option 4 is correct. So in this question, we have to find out the absorption line of highest frequency. Now we know absorption spectrum means it is absorbing the energy. It is moving from lower orbit, lower stable orbit to higher stable orbit. It is absorbing. If say higher to lower, it is emission. We are talking about here in this case absorption line of the highest frequency. So first lower to higher. This is very important. Number 1. And number 2, when it say very close, so n is equal to 1, 2, n is equal to 2, means here the energy given as minus 13.611 square electron volt. For this is say minus 13.6 upon 2 square means 4 electron volt, and the difference is maximum in comparison to other cases. So here E1 minus E2 comes here minus 10.2. So this much energy is required here, positive. If it is, this is the energy absorbed, it will jump from first orbit to second orbit. It is absorbing energy. So we have to give this much energy by any means. Hello. We know the energy is equal to h nu. H is the Planck constant, nu is the frequency. If the energy is maximum, frequency is also maximum. Then it will. So option here 1 correct. Hello, in this question, in an electron hydrogen atom revolving in circular track of radius 5.3 into 10 to the minus 11 meter and velocity 2.2 into 10 to the 6 meter per second, and the proton around the proton. The frequency of electron moving around the proton is, now we know the frequency is the reciprocal of the time period and we know time period is distance to pi r upon v. So you can see is given as v upon pi r, and speed or velocity given here 2.2 into 10 to the power 6 upon pi 3.14 r. Radius is 5.3 into 10 to the power minus 11 meter. Solve it here, comes roughly 6.6 into 10 to the power 15 hertz. So option 4 is correct. Hello. In this question, we are supposing, not the fact, supposing an electron attracted towards the origin by this force K upon R, where C is constant. R is the distance of electron from the origin. By applying the Bohr's model, this new system, the radius of nth orbit of the electron is found to be Rn, and the kinetic energy here is Tn, the kinetic energy. Then we have to find the relation, dependency of kinetic energy and the radius on n. So we know here, as per the Bohr theory, here this force is given K constant upon R. This is the attraction force between the electron and the nucleus, and this is the centrifugal force mv square upon r. We equate here K upon R equal to mv square upon r, or cancel out here. So the kinetic energy half mv square, putting the value of here mv square is k simply, so it is k by 2. The kinetic energy is k by 2. The kinetic energy is not depends on n, only the radius. So now the second postulate of the Bohr's model is angular momentum equal to mvr equal to n h upon 2 pi. H is the Planck constant, n is the here. Now R. Here R can be written like n h upon 2 pi mv. Now from the first equation, mv square equal to k, so v square is equal to say k by m, and v will be root of k by m. We are putting this in this equation, suppose 3. So R equal to n h upon pi m, and p is under root k by m. Here this quantity inside the bracket is constant quantity. It means R is directly proportional to n. Now using this result, R is directly proportional to n radius, and kinetic energy is not depending on n. So here, considering both these results, you can say here option 2 is correct. In this question, the wavelength of the first line of Lyman series of hydrogen, this is 1216 from. The wavelength of the second line of this same series, Lyman series, is, we have to find out the wavelength for the Lyman series in second line. Now we know the formula of wavelength 1 by lambda equal to R, Rydberg constant, and Lyman series means here lower one is say 1, and first line means here 1 to 2. If we solve this 1 by lambda, first case, so say lambda 1, R 1 minus 1 by 4, that is 3 by 4, say equation 1. For the second line, say wavelength is suppose lambda 2 R, ये 1 ही होगा, ये Lyman series है, and then second 2 means here now 3. Second line, that is say R 1 minus 1 by 9, that is 8 by 9, say equation 2. Now if we divide equation 1 by 2, we get here 1 by lambda 1 upon 1 by lambda 2 means lambda 2 divided by lambda 1. Here R 3 by 4, 8 by 9 are cancel out. This will be 27 by 32. So here lambda 2 will be 27 by 32 into lambda 1 given in the question 1216 angstrom. If we calculate here, is coming here 1026 angstrom. So option 2 is correct. Option 2 is low. This question, the Rydberg formula for the spectrum of hydrogen atom, where all the terms having the usual meaning. Here we know the Bohr's hypothesis, first attraction force is equal to centrifugal force. This way 1 upon 4 pi epsilon naught E square upon R square equal to mv square upon R. 1 R cancel out. So here this equation 1 E square upon 4 pi epsilon naught r equal to mv square. And second postulate, angular momentum equal to mvr equal to say n h upon 2 pi, where time constant n is the here. Now from second equation, you can write here r equal to n h upon 2 pi m v and 3. Now we are putting the value of r in equation 1. We get e square upon 4 pi epsilon naught r. आर की वैल्यू इक्वेशन 3 से पुट कर रहे हैं एन एच चला जाएगा ये पाई एम वी इक्वल टू एम वी स्क्वायर. एक वी कैंसिल हो गया यहाँ से, तो एम ऑल्सो कैंसिल. टी कैन बी रिटर्न एज सी स्क्वायर, कैंसिल टी स्क्वायर upon 2 epsilon naught and h. Now kinetic energy here, the kinetic energy formula half mv square. So here half m v square means here per 4 upon 4 epsilon naught square n square h square. We know kinetic energy and the total energy modulus, they are equal, but total energy is negative. That's why we have taken the magnitude. So kinetic energy and total energy is the same formula. So the total energy will be equal to, let's say E is m e to the power 4 upon 8 epsilon naught square h square and 1 by n square. We can write like this. Let's say equation 5. And the energy transition from initial shape this to final this or the reverse. If initial lower orbit to higher orbit, absorption spectrum, higher to lower, it is an spectrum. So final energy का, so we know h nu equal to h by lambda, the energy m e square by 8 epsilon naught square 1 upon n I square minus 1 by n f square. Or to the absorption spectrum, h nu initial final can be written like E m e to 4 upon 8 epsilon naught square h square 1 upon n f square minus 1 upon n I square. So option 2 is correct. Hello, in this question we have to find out the spectral series for UV rays. Here Lyman series बहुत बार का याद किया क्वेश्चन है, तो ये सारे ऑप्शंस याद रहने. Lyman series, Bohr series, Pastchen, Bracket, Pico and Humphrey series. So this option is correct. Hello, in this question there are two hydrogen atoms, the ground state, they collide inelastically. We know in inelastic collision there is always some loss of energy, not inelastic. Now maximum amount of kinetic energy loss means here the potential energy associated with both H atom is 2 times 13.6 electron volt. That is say 27.2 electron volt. Now after collision, first electron transferred or excited the next orbit, that is the second orbit, and second electron remains in the first orbit. So now the total energy is given as first electron, that is 13.6 upon 2 square, and first one remains goes to this and second one remains in the first orbit. Solve it, that is the 17 volt. Now change in energy, in the previous case change in the energy, that is the energy only. So change in energy equal to initial energy here minus final energy, that comes here 10.2 electron volt. Whatever change in energy, that is converted into loss in the kinetic energy. So this is the kinetic energy reduced to 10.2, means option 1 is correct. In this question, the radius of the first orbit n is equal to 1. Out of 4 options, let us say which one is correct. Now we know the radius formula r equal to n square epsilon naught h square upon m by z square. If everything is constant, n is equal to 1, h, m, pi is constant other than z, that z is variable. In that case, r is inversely proportional to z. And out of 4 options, z is maximum for lithium WNI. Z for lithium is 3, means R should be minimum for lithium. R is minimum for, so option 1 is correct. Hello, in this question the de-Broglie wavelength. First of all, de-Broglie wavelength we know this is h upon mv, and the circumference formula क्या होगा? This is 2 pi r. Now we know formula of radius n square epsilon naught h square upon z e square by m, and velocity speed is 1 by n z e square upon 2 epsilon naught h. Now put in one equation value of v. So from equation 1, lambda equal to h upon mv. It means z e square upon n epsilon naught h. And now circumference from equation 2, circumference equal to circumference or perimeter, both are same thing here. It is saying 2 pi r. We have r here, n square epsilon naught h square upon z e square pi m. Here you see equation 3 for lambda. So putting the value of n is equal to 1. If we put here n is equal to 1, equation 3 and equation 4, then equation 3 and 4 both are same. So we can say now lambda equal to the circumference is the result. So option 4 is correct. It is only possible for the first orbit. Otherwise, hello. In this question, when an electron is jumping from lower to higher, it is absorbing the energy. Now we know formula of kinetic energy and the potential energy given by equation 1 and 2. And if n increases, means lower orbit to higher orbit, then only then you can say n increases. Lower to higher, if n increases, then kinetic energy is decreases. By increasing n, from the first equation we can say kinetic energy is, and potential energy numerical value also decreases, but because of minus sign it increases. So option 3 is hello. In this question, electron in hydrogen atom makes a transition from N1 to N2. The time period of electron in the initial state is 8 times than final state. We have to find out the value of N1 and N2. Here the time period is given at 8 times time period final or 2. Here 1 2 take 1 2 also. So this is the relation given. See here is time period. Now we know time period equal to 2 pi r upon v, and formula of we know the radius. We know the formula of radius given by equation 3 and speed given by equation 4. Put the value of r and v, take the values of r and v in equation 2. We get the time period by r upon v comes here 2 pi n cube. Now we get say n cube r cube epsilon naught square divided by pi m per 4 and z square. Here z is constant for hydrogen atom, z is equal to 1. Everything in the bracket, that is the constant quantity, So t square is directly proportional to n cube. T is directly proportional to n cube from the above discussion. Now here, so T1 divided by T2 is n1 by n2 power, and from the equation 1 it is say T1 means 8 T2 divided by T2, that is n1 upon n2. So n1 by n2 will be 2, and here option 1 satisfies this condition only. Option 1 is correct.